Hello all students, very good morning to one and all present here and welcome to Enlightened Educator. So today I've told you that I would be coming live yesterday due to some reasons I couldn't come. So today I'm coming live speaking to you with respect to mesh analysis again. So this is a session on network analysis crash courses and this is your fourth or fifth session with respect to the network analysis crash courses. So today we're going to discuss with respect to the mesh analysis problem from your scheme of valuation, right? There is one question which is very much different from all the problems. Before that, let us see what are the certain necessary things you need to know, right? We have already discussed what is the procedure for mesh analysis, and we have also discussed how to solve mesh analysis, right? The same thing, the procedure itself, but some of the tips and tricks you need to know before solving the mesh analysis, right? That is what I'm coming to discuss here. And one more thing to tell you is that if you know those basics, you can easily crack mesh analysis without fail, right? And there are some of the problems which is very much confusing to you, or wherein they'll give some V terminologies or I terminologies in the where in some of the places wherein that makes you confused. So I have found out the problem, that kind of problem of one kind. Okay, so after the problem one the sikkidange I'm finding another problem. If I get it, I'll do it today. I thought of doing two problems because those problems will only make you into a big problem, right? So those problems, what happens is that when you see that, you get confused what to do, what not to do. You know the mesh analysis procedure. If the question is given directly, if you know the polarities, you can just try to apply, right? You can just try to apply the mesh analysis and get it resulted. You also know what is the formula for power, and you also know what is the um, what is the formula for power, how to find the voltage and currents and all. But what is that going to happen is that when you get that certain terminology, that is say V or I in any of the places, you will get it confused. I've got B in this place or I in this place, what I have to do in the diagram, what I have to do. So those kind of problem I got it one. So other one I'll get it, if I get that, I'll just teach it to you, because I also want to teach that so that you won't get confused. I got to know that you are losing your marks in mesh analysis there itself, right? If the problem is given directly, you can do it. I know, right? ನೀವು ಮಾಡ್ತೀರಾ ತುಂಬಾ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕೊಟ್ಟಿದ ತಕ್ಷಣನೇ ನೀವೆಲ್ಲಾನು ಮಾಡ್ಬಿಡ್ತೀರಾ. But if that kind of problem comes to you, so then it is a problem for you. So that is why I don't want that problem to happen, and I am here to help you out with that problem. Fine. Okay. Yeah. So first thing is, need to know with respect to the polarity only. So polarity, if you don't know. So polarity, if you don't know, say, then what is that going to happen? Then you can't even do the mesh analysis problem, right? What is the polarity? The polarity is nothing but the polarity which is being suggested by the VTU, right? If you see the network theory question papers, so if you try to solve the problems in the network theory question paper, so what is that going to happen is that so when you just try to solve it, you will get to know what is the polarity that has been taken by the V2 people, right? If you just take a problem from network theory question paper, mesh analysis problem, if you try to solve it according to your polarity, the basic polarity that everybody uses is positive to negative is negative, and negative to positive is positive. The basic polarity they use. But what is that going to happen is that sometimes the equation might differ, right? Equation might differ or equation will differ. I've seen equation will differ for that. So what is that going to happen is that when you use this particular polarity and solve that particular problem, so you will get to know what is the difference between the both, right? So I just retell it to you again. Don't get confused. Very first thing is, have a network theory question paper. Start solving the mesh analysis problems that is given in the network theory question paper. Then what is have to do is that you have to use this polarity first, right? Don't use the polarity what I have told. Okay, this is just an experiment that you have to do it now, right? This is just an experiment that you have to do it now. I'm telling you the experiment what you have to do, right? Okay. So this is an experiment. You're not going to do it in real. If you do it in real, then it will be a problem, right? Do it in real in the sense when you do it in an examination, right? When you go to the examination hall and when you do this, this becomes a problem. So I'm telling you, please do take up an experiment. Fine. Okay. I've already done this experiment. If anybody is new to this channel, so if anybody is new to this channel and if anybody haven't seen a network ಮೆಷಿನ್ ನೆಟ್ವರ್ಕ್ ಅನಾಲಿಸಿಸ್ ಪ್ಲೇ ಲಿಸ್ಟ್ ರೈಟ್. ಮೆಷಿನ್ ನೆಟ್ವರ್ಕ್ ಅನಾಲಿಸಿಸ್ ಪ್ಲೇ ಲಿಸ್ಟ್ ಯಾರಾದ್ರೂ ನೋಡಿಲ್ಲ ಅಂತಂದ್ರೆ ಅವರಿಗಾಗಿನೇ ನಾನು ಕ್ರಾಶ್ ಕೋರ್ಸ್ ಮಾಡ್ತಾ ಇದೀನಿ. ಬಿಕಾಸ್ now it is not the time to see the whole playlist. And one more thing to add on, I am not updating the playlist anymore, right? Mission network analysis playlist na ನಾನು update ಮಾಡ್ತಾ ಇಲ್ಲ. Mean I am not doing any videos on that particular mission network analysis playlist, right? Why? Because I have already told you there is less amount of time, and within this time you are supposed to what? You are supposed to learn it in a simpler manner. You need not to go that much complex by taking more and more problems and solving it. It is not the time. It is only the time to understand the tips and tricks for each and every topic, and it is only the time to learn the concept within 2 sessions. That is 2 sessions ಅಂದ್ರೆ ನಮ್ದು ಒಂದು ಸೆಷನ್ 48 minutes ಇಲ್ಲ 50 ಆಗುತ್ತೆ, ಇನ್ನೊಂದು ಸೆಷನ್ ಅಷ್ಟೇ ಆಗುತ್ತೆ. ಸೊ ಅದೇ ತರ ನೀವು 3 hours ಅಲ್ಲಿ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ನ ಕಲಿಯೋ ತರ ಆಗ್ಬೇಕು, ರೈಟ್? ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ನ ಕಲಿಯೋ ತರ ಆಗ್ಬೇಕು. ಸೊ ದಟ್ ಇಸ್ ವಾಟ್ ಇಸ್ ಮೈ ಅಜೆಂಡಾ. So that is why ಇಷ್ಟನ್ನ ಹಾಕೊಂಡು ನೀವು ಈಗ ಮಾಡ್ಕೋಬೇಕು. You don't have that much of time. Okay, I know. That is why I have taken network analysis crash courses, and ದಯವಿಟ್ಟು ಈ crash courses ಗೆ ನೀವು support ಅನ್ನ ಕೊಡಿ. I need more and more support from your side, because I am helping you how to learn the concept within 2 to 3 sessions, right? 2 to 3 sessions ಅಲ್ಲಿ ನಿಮಗೆ ಮುಗಿಯೋ ಸಾಧ್ಯತೆನೇ ಇಲ್ಲ. ನಿಮ್ಮ ಕಾಲೇಜ್ ನಲ್ಲಾದ್ರೂ ಎಕ್ಸೆಸ್ ಆಗಿ ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿಸ್ತಾರೆ, ಹೌದಾ? ಎಕ್ಸೆಸ್ ಆಗಿ ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿಸ್ತಾರೆ. ಬಟ್ ನಾನೇನ್ ಮಾಡ್ತಾ ಇದೀನಿ ಅಂದ್ರೆ ಎಕ್ಸೆಸ್ ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿಸೋದ್ರಿಂದ ಈಗ ನಿಮ್ಮ ಟೈಮ್ ಲಿಮಿಟ್ ಅನ್ನ ನೋಡೋದಾದ್ರೆ ವಿ ಕಾಂಟ್ ಡೂ ದ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇನ್ ಎಕ್ಸೆಸ್. ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಓನ್ಲಿ ಲರ್ನ್ ಇಟ್ ಇನ್ ಎ ಶಾರ್ಟ್ ಅಂಡ್ ನೀಟ್ ಮ್ಯಾನರ್, ಸೊ that will be in your mind, and when you go to the examination hall you will just crack that particular exam in a neat and clean manner. So actually it is not that how much problem you practice. I'm repeatedly telling you, it is not that how much problem you practice. It is not that how much problem you, what I can say, work out, right? How much problem you work out, and it is not that how many hours you spend on this particular subject. But what is that going to happen is that you have to understand the concept well, right? You have to understand the concept well, and if you understand the concept well only, you can put it in an examination, right? That is what is very important thing. Many people will say, ma'am, I have kept that much of time for the subject. I have kept this much of time for the subject. I work more and more time with respect to the subject. Say I work for 4, 5, 6 hours and all, but I am not getting the result. That is what is the main problem, because you are not learning it in a neat and clean manner, or what I can say, you are not doing a smart work, right? Smart work ನೀವು ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ, so then what's that going to happen? Nothing will going to happen. You lose your exams ಅಷ್ಟೇ. So when you do smart work, smart work in the sense understanding, hard work in the sense by hearting, right? Okay, so I'll just tell you that also. So ದಯವಿಟ್ಟು ಇದನ್ನ ನೋಡಿ, ಏನಕ್ಕಂದ್ರೆ ತುಂಬಾ ಉಪಯೋಗ ಇದೆ. ನಾನು ಸುಮ್ಮನೆ ಬಂದು ನಿಮ್ಮ ಹತ್ರ ಲೈವ್ ಅಲ್ಲಿ ಮಾತಾಡ್ತಾ ಇಲ್ಲ. ಐ ಆಮ್ ನಾಟ್ ಸ್ಪೀಕಿಂಗ್ ಎನಿಥಿಂಗ್ ವಿಚ್ ಇಸ್ ನಾಟ್ up to the this thing, right? Okay, yeah. So this is hard work means your by hearting case, right? Hard work ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ತೀರಾ, ತುಂಬಾ ಕಷ್ಟಪಟ್ಟು you will by hearted. By hearted. Smart work is nothing but. So what is a smart work? To be frank, what is a smart work? A smart work is nothing but you just practice it. You just understand the concept and practice it in a well manner, right? You will just understand the concept. When you understand the concept only, what happens? When you understand the concept only, you will get to know what is inside the concept, and if any kind of problem is given from the concept, how I can tackle it, right? That is what is understanding, right? If you just only try to by heart, then you don't get to know what is inside the concept. When you understand only, you will get to know what is inside the concept, and you will see that if any problem is given of that type, what I have to do, that you will know the tips and tricks and will apply according to the problem, right? That is what is understanding. So better do smart work. Better do smart work. Don't underestimate anybody. So it is like, if you even do it, if you even spend 3 to 4 hours also, you can crack your exams. I'm 100% sure and confident, right? So I have seen what is the agenda with respect to this subject, right? Ellaru heltare you can't clear the subject in the first attempt, because the question paper will be very much difficult. If you study 100 problem, it will be 101th problem you get anta, but it is not. It is not, right? 100 ಪ್ರಾಬ್ಲಮ್ ಕೊಡ್ಲಿ, ನೀವು ಓದಿರೋ 100 ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ 100 ಪ್ರಾಬ್ಲಮ್ ಒಳಗೆ ಕೊಡ್ಲಿ, ಇಲ್ಲ 100 ಪ್ರಾಬ್ಲಮ್ ಬಿಟ್ಟು 101ಗೆ ಹೋಗ್ಲಿ ಪರವಾಗಿಲ್ಲ. ನೀವು ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿದ್ರೆ, ನೀವು ಕಾನ್ಸೆಪ್ಟ್ ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡಿದ್ರೆ, ಈಗ ಮೆಶ್ ಅನಾಲಿಸಿಸ್ ಐ ಆಮ್ ಡೂಯಿಂಗ್ ಇಟ್. ಇಫ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ಇನ್ ಮೆಶ್ ಅನಾಲಿಸಿಸ್, if you try to see what is all inside the mesh analysis, if you understand what is the very basics of mesh analysis, how do I have to solve for mesh analysis for dependent sources and for complex problems and for complex dependent sources, right? So ee ತರ ಎಲ್ಲ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿದ್ರೆ, if you get 101 problem also you can solve it. Understanding always makes you perfect. By hearting doesn't make you perfect. By hearting is just, it will be going into your head at that period and you will just even vomit it in your examination at that period, and afterwards everything will get forgotten, right? If you understand it, you'll remember it for some time, right? I can say it might be near or so, right? It might be a year or so, you'll remember if you understand the concept. Howda? So that is why try to understand the concept without fail. That is why I'm telling you, do this experiment first. See the experiment. New students who are watching this, see the experiment and what is the result you get in the experiment you see, and then you start solving with the mesh analysis, right? I'll come back to this. Okay. So experiment ಮಾಡಬೇಕು. ಏನು ಮಾಡಬೇಕು? Take a network and a theory question paper. Take one problem from mesh analysis. What you have to do is you need to apply this what I can say, the polarity, that is positive to negative is negative and negative to positive is positive for all the voltages, and for all the resistance what I can say it is for all the resistance what I can say it is what I can say negative, right? Negative haki resistance gala aita. So when you do this experiment, what is it going to happen is that, so what is that going to happen is that you will not get the required, what I can say, the equation that is being given in the question paper, right? And then in answer script alli that is the scheme of valuation alli, if you can see here in the scheme of valuation, whatever the equation you are getting, this equation you are getting, you won't get it, right? Whatever the equation you are getting, you won't get that, right? You won't get that. So that is why what is that going to happen is that don't use that particular. What you have to use is that, you have to use that as negative to positive is negative and positive to negative is equal to positive. For all the voltages and for all the resistances it is positive. You are supposed to use that, right? So ಏನು ಮಾಡ್ತಾರೆ resistance ಗೆ positive to negative is negative ಅಂತಾನೆ ತಗೊಂಡ್ಬಿಡ್ತಾರೆ resistance ಗೆ, ಹೌದಾ? But don't do that. Take this particular. If you take this particular, you get the proper what I can say, the resultant. If you just check with the video answer scripts, you will get to know all this in detail and clean manner, right? I'm sure that in the video paper they have used this one. They have used this one. Okay, they have used this one, and I have also checked with the proof, and I'm telling you, I've also shown you the proof. If anybody is very new to this session, so ದಯವಿಟ್ಟು ಈ ಒಂದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅನ್ನ ನೀವು ಪ್ರಯತ್ನ ಮಾಡಿ. ಓಕೆ, ಟ್ರೈ ಟು ಡೂ ದಿಸ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. ಓಕೆ, ಸೊ ಎರಡನ್ನೂ ಕೊಟ್ಟಿದ್ದಾರೆ ಕಂಫರ್ಟಬಲ್ ಇರಲಿ ಅಂತ, ಬಟ್ ನಿಮ್ಮ ವಿಡಿಯೋ ಅಲ್ಲಿ ಏನು ಹೇಳ್ತಾರೆ ಅದನ್ನ ನೀವು ಫಾಲೋ ಮಾಡಬೇಕಾಗತ್ತೆ, ರೈಟ್? ದಿಸ್ ಇಸ್ ವಾಟ್ ಇಸ್ ದ ಫಸ್ಟ್ ಟಿಪ್ಸ್ ಅಂಡ್ ಟ್ರಿಕ್ಸ್ ಯು ನೀಡ್ ಟು ನೋ. Second is you need to know how to apply mesh analysis, right? How to apply mesh analysis, if you know, then you can get to know it in a easier and a neat manner, right? Then other small tips and tricks you need to know. If you know that, you can easily crack your mesh analysis problems, right? And main thing, you need to know the Cramer's rule, right? Main thing, you need to know the Cramer's rule, right? I'll just update you with respect to the Cramer's rule. Whether I have done or not, I don't know. So I'll just check it once. So I guess I've done it. If I have not done it, what is that going to happen is that I will just do with respect to the Cramer's rule in the next session, right? Next session alli nanu ಏನು ಮಾಡ್ತೀನಿ, ನೆಕ್ಸ್ಟ್ ಸೆಷನ್ ಅಲ್ಲಿ ಅಂದ್ರೆ ಇನ್ನೊಂದು ಪ್ರಾಬ್ಲಮ್ ತಗೊಂಡ್ ಬರ್ತೀನಿ. ಆಚೆ ಸೆಷನ್ ಅಲ್ಲಿ ನಾವು Cramer's rule ಡೀಟೇಲ್ ಆಗಿ ಮಾಡೋಣ, ಆಯ್ತಾ? ಸೊ ಇದು 4 ಸೆಷನ್ಸ್ ಹೋಗ್ತಾ ಇದೆ, ಡೋಂಟ್ ವರಿ, because ಕೆಲವೊಂದು ನಾನು ಮಾಡಿಲ್ಲ ಅನ್ಸುತ್ತೆ. If I have not done, what I'll do is that I'll just do a normal session for Cramer's rule. Okay, so Cramer's rule ಗೆ ಒಂದು ನಾರ್ಮಲ್ ಸೆಷನ್ ಅನ್ನ ಮಾಡ್ತೀನಿ ನಾನು ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ. If I have done, what I'll do is I'll just attach the link in the description box for this video. Fine, ಈ ಲೈವ್ ವಿಡಿಯೋ ಕೆಳಗಡೆ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ದಯವಿಟ್ಟು ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳಿ Cramer's rule. Okay, yeah. So now what is that going to happen? Why you require Kramer's rule is because if you have complex equations, you can't solve it using the calculator. You need to solve it using the Kramer's rule itself. That is why you need to know with respect to that, right? Many ask you a question, ma'am, do I have to use the Kramer's rule for the normal equations, not the complex equations, normal equations? No, right? So when I just check with the video answer script or video scheme of valuation examination do video scheme of valuation check ಮಾಡಿದಾಗ ಅವರು ನಿಮಗೆ ಎಲ್ಲೋ ಕ್ರೇಮರ್ಸ್ ರೂಲ್ ಬಗ್ಗೆ ಹೇಳಿಲ್ಲ, ಹೌದಾ? ಎಲ್ಲೋ ಅವರು ಕ್ರೇಮರ್ಸ್ ರೂಲ್ ಸಾಲ್ವ್ ಮಾಡಿ ಅಂತ ನಿಮಗೆ ಮೆನ್ಷನ್ ಮಾಡಿಲ್ಲ, ಅವರು ಡೈರೆಕ್ಟ್ ಆಗಿ ಆನ್ಸರ್ಸ್ ಬರ್ದಿದ್ದಾರೆ. ಸೊ ಅದನ್ನೊಂದನ್ನ ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳಿ ನೀವು. ಯು ಕ್ಯಾನ್ ಡೈರೆಕ್ಟ್ಲಿ solve it in the calculator and directly write the resultant of that particular equations in their answer script, right? Okay, so now let us start with the particular problem. So let me show you the problem. So e problem na ನಿಮ್ಮ ಎಕ್ಸಾಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ. I don't know why this problem has been asked you for the exam, right? I'm repeatedly telling you, I don't know why this problem is asked in the examination. ಯಾಕೆ ನಾನು ಈ ತರ ಹೇಳ್ತಾ ಇದೀನಿ? Why I'm telling like this is because, so in this problem you also make use of superposition theorem which comes after this, ಹೌದಾ? ಸೂಪರ್ಪೊಸಿಷನ್ ಥಿಯರಮ್ದು ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ನೀವು ಬಳಸ್ತೀರಾ. ಸೊ ಹಾಗಾಗಿ ನೀವೇನ್ ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಯೂಸ್ ದ ಮೆಶ್ ಅನಾಲಿಸಿಸ್ ಆಲ್ಸೋ ಅಂಡ್ ದ ಸೂಪರ್ಪೊಸಿಷನ್ ಥಿಯರಮ್ ಆಲ್ಸೋ ಹಿಯರ್. ಸೊ ಹಾಗಾಗಿ ಈ ಪ್ರಾಬ್ಲಮ್ ನಿಮಗೆ ಹೇಗಂದ್ರೆ ಎರಡು ಮಿಕ್ಸ್ ಆಗಿ ಇಲ್ಲೇ ಬಂದ್ಬಿಟ್ಟಿದೆ. ಸೊ ಈ ಪ್ರಾಬ್ಲಮ್ ನ ನಿಮಗೆ ಸೂಪರ್ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ರು ಆಗ್ತಿತ್ತು ಅಂತ ನನಗೆ, ಐ ಡೋಂಟ್ ನೋ, ಬಟ್ ಯಾ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ಇಟ್, ಸೊ ಲೆಟ್ ಅಸ್ ಸಾಲ್ವ್ ಇಟ್. ಓಕೆ, ಯಾ. So see here students, what is that going to happen is that use mesh analysis, what I can say, to determine the V1 and the power being supplied by the dependent current source in the circuit as shown in the figure. You have to determine the V1. Where is V1 present? V1 is present over here. So ನಿಮ್ಗೆ ಇಲ್ಲೇ ಕನ್ಫ್ಯೂಷನ್ ಸ್ಟಾರ್ಟ್ ಆಯ್ತು. ಯಾಕೆ ಕನ್ಫ್ಯೂಷನ್ ಸ್ಟಾರ್ಟ್ ಆಯ್ತು? Why you end up with the confusion is because here there is a 5 ampere current present in mesh 1, and if there is any current present in the mesh, that current will be equal to the mesh current, right? So here you have 5 ampere current, howda? 5 ampere current ಇದೆ, and this is the mesh 1 current is I1, then your I1 becomes equal to 5 ampere. Then what you have to do with this mesh, alva? So ನೀವು ಸಾಧಾರಣ ಒಂದು ಮೆಶ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಇದ್ದರೆ you will take that particular mesh current as the given current in the mesh, right? ಅದು ತಗೊಂಡ್ಮೇಲೆ ನೀವು ಆ ಮೆಶ್ ನ ಮತ್ತೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಕ್ ಹೋಗ್ತೀರಾ? ಮಾಡ್ತೀರಾ? You don't do it, right? When you take I1 as 5 ampere, so here 5 ampere is present. So this is mesh current I1, this is mesh 1. So this mesh current I1 becomes equal to 5 ampere. After that, will you go to that mesh and solve something? No, you will just neglect that mesh. That mesh is neglected, right? As I've seen in normal problems, we neglect that mesh, right? But now we have to find V1, right? We have to find V1. To find V1, V1 is present in 5 ampere. Now what you have to do? Here rises a question for you, right? So ಈ ತರ ತಲೆ ಕೆಡ್ಸೋಂಗೆ ಕೊಡ್ತಾರೆ. ಸೊ ಹಾಗಾಗಿ ನೀವೇನ್ ಮಾಡ್ಬೇಕು, ಇದ್ರ ಬಗ್ಗೆ ಸ್ವಲ್ಪ ಎಚ್ಚರ ವಹಿಸ್ಬೇಕಾಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಈ ತರದೊಂದು ಪ್ರಾಬ್ಲಮ್ ಅನ್ನ ನಾನು ನಿಮ್ ಮುಂದೆ ಹೊತ್ತು ತಂದಿದ್ದೀನಿ, ಆಯ್ತಾ? ಎಸ್. ಅಂಡ್ ಇವಾಗ ಸೊ ನೋಡಿ, ಇಲ್ಲೂ ಇದೆ V1, ಹೌದಾ? ಇಲ್ಲೂ ಇದೆ V1, ಹೌದಾ? ಇಲ್ಲೂ V1 ಇದೆ, ಇಲ್ಲೂ V1 ಇದೆ, ಬಟ್ ದಿಸ್ ಇಸ್ ಯಾರ್ ವೋಲ್ಟೇಜ್ ಡಿಪೆಂಡೆಂಟ್ ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ವೋಲ್ಟೇಜ್ ಡಿಪೆಂಡೆಂಟ್ ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ ಇದೆ which is in between the two meshes, and here this is current dependent, once again the current source, sorry, current dependent voltage source, this is okay, CDVS, current dependent voltage source ಇದೆ. So now we can see if we have a current dependent voltage source, once again what is that going to happen? This is a mesh I3 for us, right? Mesh 3, okay, mesh 3 current is I3. So now my I3 becomes equal to 0.01 V1, right? ಇವಾಗ ನಾವು V1 find ಮಾಡೋದಕ್ಕೆ you can't what I can say, you can't take any of the meshes and do the what I can say, find the V1, right? ನಾವೇನ್ ಮಾಡ್ಬೇಕು, ಇಲ್ಲೇ V1 ಇರೋದ್ರಿಂದ ಇಲ್ಲೇ ನೀವು V1 ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೇಕಾಗುತ್ತೆ. ಫಾರ್ ದಟ್ ವಾಟ್ ಯು ಹ್ಯಾವ್ ಟು ಡೂ, ಇಫ್ ಯು ನೋ ದ ಸೂಪರ್ ಪೊಸಿಷನ್ ಥಿಯರಮ್, ಯು ಕ್ಯಾನ್ ಡೂ ದ ಸೂಪರ್ ಪೊಸಿಷನ್. ಏನ್ ಮಾಡ್ತೀವಿ, if they ask you to find any of the voltages, so what is that going to happen is that you need to make this current as what? So you need to make this current as an open circuit, and then you have to start solving, ಹೌದಾ? ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಮಾಡ್ಬಿಟ್ಟು ಏನ್ ಮಾಡ್ತೀರಾ, what is the superposition theorem? Superposition theorem is nothing but if there is a linear bilateral network having two or more independent sources, so the response in any element equal to algebraic sum of all the responses, that is due to each independent sources acting independently. That is your V1 is equal to, if you want to find V1, so what is V1? So ಈಗ V1 find out ಮಾಡಬೇಕು ಅಂದ್ರೆ it is V1 dash plus V2 dash plus V3 dash and so on ಅಲ್ವಾ. ಸೊ ಆ ತರ ಇಲ್ಲಿ ಪ್ರೊಸೀಜರ್ ಬರುತ್ತೆ, ಅದನ್ನ ನೀವು ಬಳಸಬೇಕಾಗುತ್ತೆ ಟು ಫೈಂಡ್ ದ V1. ಸೊ ನೀವು ಇಲ್ಲೇ ಕನ್ಫ್ಯೂಸ್ ಆಗೋಗ್ತೀರಾ, ಫಸ್ಟ್ ಇಲ್ಲೇ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ಬಿಡ್ತೀರಾ. ನೀವು ಯಾವತ್ತೂ ನೀವು ಒಂದು ಕರೆಂಟ್ ನ ನೀವು I1 is equal to 5 ಆಂಪಿಯರ್ ಅಂತ ಆದ್ಮೇಲೆ ನೀವು ಮುಂದಕ್ಕೆ ಆ ಮೆಶ್ ಸಾವಾಸಕ್ಕೆ ಹೋಗಲ್ಲ. ನೀವು ನೆಕ್ಸ್ಟ್ ಯಾವ್ದಿದೆ ಮೆಶು ಅದಕ್ಕೆ ನೀವು ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀರಾ. ಬಟ್ ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕಾಗುತ್ತೆ, ನಾವು ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಮೆಶ್ ಆಲ್ಸೋ ಹ್ಯಾಸ್ ಟು ಬಿ ಸಾಲ್ವ್ ಯೂಸಿಂಗ್ ದ superposition theorem. This particular mesh also has to be solved using superposition theorem. What you have to do is you have to make these two currents as open circuited and start solving the according to the superposition theorem. ಆಯ್ತಾ, ಈ ಮೆಶ್ ಬರೋದಿಲ್ಲ, ಅದಕ್ಕೆ ನೀವೇನ್ ಮಾಡ್ಬೇಕು, ಎರಡು ಸಪರೇಟ್ ಆಗಿ ಮೆಶಸ್ ನ ತಗೊಂಡು ಟು ಟೇಕ್ ಮೆಶ್ ಒನ್ ಸಪರೇಟ್ಲಿ ಬೈ keeping the 5 ampere as open circuited, and here you have to, what I can say, take this mesh separately, and here you are going to keep the 0.01, that is V1, it is current dependent voltage source as open circuited, and then you are going to find out V1 from this. So idrinda nimge V1 barutte. So ivaga nimge idrinda ಏನು ಬರುತ್ತೆ voltage andre, it is VAB voltage that you are going to get. If there is no voltage present here, what you have to do is you need to take this as terminal A, you need to take this as terminal B and tell it as VAB. So ivaga nimge question arise agutte. So ma'am, here we want to find out V1, so we are going to make this 5 ampere as open circuited, and then we are going to solve this by using any of the methodologies, right? ನಿಮಗೆ ನಾನು ಹೇಳಿದ್ದೆ ಸೂಪರ್ಪೊಸಿಷನ್ ಥಿಯರಮ್ ಅಲ್ಲಿ ನೀವು ಕರೆಂಟ್ ನ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಮಾಡಿ ವೋಲ್ಟೇಜ್ ನ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಮಾಡಿದಾಗ ನಿಮಗೆ ಯಾವ ಒಂದು ಡಯಾಗ್ರಾಮ್ ಬರುತ್ತೆ, ವಾಟ್ ಇಸ್ ದ ಡಯಾಗ್ರಾಮ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್, ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಡಯಾಗ್ರಾಮ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು solve it using mesh analysis, nodal analysis, or your V is equal to IR, I is equal to V by R, or your current dependent or voltage dependent source, right? ನೀವು ಮಾಡಬೇಕಾಗಿರುವಂತ ಒಂದೇ ಪ್ರೊಸೀಜರ್ ಏನು, to make a current as open circuit or voltage as short circuit according to the problem, and then what is the circuit you are going to get. For that you are going to do this procedure, that is mesh, node, current divider, voltage divider, V is equal to IR, I is equal to V by R. ಹೌದಾ? Okay. So but ನಾವು ಯಾಕೆ ಇಲ್ಲಿ ಮಾಡಬೇಕು, why we have to why we have to do the same process here, ma'am? Why we have to, what I can say, that is keep your A and B, that is do this process. That means you have to open circuit the current dependent voltage source. Why we have to do that? Why we have to do that is because here you can see the question, you have to also find, not only find the voltage V1, you have to find the power being supplied by the dependent source in the circuit. So dependent source in the circuit andre yadu? So dependent source in the circuit is this one. You have to find out the power that is being supplied by this dependent current source. So dependent current source is this one alva. This is dependent current source, right? So you have to find the power that is being supplied by the dependent current source. So what is the power formula? Power formula is nothing but that is the voltage into what? Voltage into I, V into I. So power is what? V into I, right? You know what is I? What is I? I is 0.01 V1. What is V? V is nothing but VAB. So you have to find out the voltage to find out the power. Power formula is V into I, and what is that going to happen is, you know the I, that is the dependent source value 0.01 V1, but you don't know what is the voltage. You don't know what is the voltage, so that is why you have to find out the voltage. You need to make use of superposition theorem by making it as an open, the 0.01 V1, that is the dependent current source, as open circuited. I hope you got it. You got the point. Yes. Now let's start solving this. This only directly comes under the mesh, like what I can say, the mesh equation direct agi hakbodu, eno tondre illa. So ivaga first ನಾನು ಏನು ಹೇಳಿದೆ, I1 is equal to 5 ampere, correct? So now we have to find for this mesh. So if you find for this mesh, so what is that going to happen is that, so please wait. Okay. So now what is that you will get it as, that is you will get it as, so I'll write it here, please wait. We have a space here. Okay. Yeah. So here I'll start. So scheme of violation ಇದೆ ತೋರಿಸ್ಕೊಡ್ತೀನಿ ಇಲ್ಲಿ ಅಟ್ಯಾಚ್ ಆಗಿದೆ ಇದಕ್ಕೆ. So it is 20 into, first it is positive 20. I've already told you please to take it as positive. So ನೀವೇನ್ ಮಾಡ್ತೀರಾ, first 50 ಇಂದ start ಮಾಡಿ because the direction is like this, no? So start from 50. So it is 50 into I2. So take it as positive. Don't go to the first one. Okay. 50 into I2. That is what I can say, plus 30 into I2 minus I3. I told you why I2 minus I3. Because there is a 30 is present between I2 and I3 and we are first considering it as I2. So that is why I take it as I2. I2 minus I3. Okay, na? And it is plus 20 into, what is that? Plus 20 into, what I can say, the I2 minus I1 students. Right? You are getting my point. Okay. So, ನಿಮಗೆ ಏನೇನು ಗೊತ್ತಾಯ್ತು ಇವಾಗ? So, ಇದು I1 is equal to 5 ampere ಅಂತ ಗೊತ್ತಾಯ್ತು. ಆಮೇಲೆ ಏನು ಗೊತ್ತಾಯ್ತು? You got to know that here there is a V1 that is present in this 5 ampere. So, how to find out V1 ಅಂತ you got to know by using the superposition theorem. And I've told you why to superposition theorem again. I've already told you because we need to find V1. Right? You got to know all those. And here also you need to do the same superposition theorem. I told it to you why you have to do it. Fine? Out. Now, which is equal to 0. Right? Okay. So now let me solve this. This you get it as 50I2. This is plus 30I2. What I can say, minus 30I3. So it is plus 20 I2 and what I can say, minus 20 I1, which is equal to 0. So now I can see that 20, 50 and 30 will give me 100. Fine. 50 plus 30 is 80, 80 plus 20 is 100. So I get it as 100 I2. So minus 20 I1. So I'll write the equation in an order. So ಇಲ್ಲಿ mistake ಮಾಡ್ತೀರಾ, ದಯವಿಟ್ಟು order ಬರೀರಿ equation. That is I1, I2, I3, not I3, I2, I2, I1, I3. Okay, yeah. So it is minus 20 I1 and what I can say, this one, which one? That is plus 100 I2 plus 100 I2, what I can say, minus 30 I3 once again, which is equal to 0, students. Fine. So which is equal to 0. Right? This is what is the equation number. How much? Equation number 2. Right? Equation number 1 is what? I1 is equal to 5. So now, so now what I'm supposed to do? So now what I'm supposed to do is that I got it as I1 is equal to 5 ampere. Right? I1 is equal to 5 ampere I got, and this is what is my equation number 2. Now what I'm supposed to do is I need to take the superposition theorem, right? If I take the superposition theorem, so superposition theorem na ಮಾಡಬೇಕಾದ್ರೆ separate ಆಗಿ ತಗೋಬೇಕಾಗುತ್ತೆ. To take this part as separate first, okay, first ಇದನ್ನ ನೋಡೋಣ. So now I have to make this 5 ampere as open circuited. So I'll do that. So I'll just take another color. So this is, I made it as an open circuited. See here, right? Open circuited. Illandre neeven madbodu. You can just directly write it like this. I will just have an eraser. Yeah. Directly write it like this, which is 20. And now here it is 0.4 V1 is for the both. Okay. Yeah. Positive to negative 0.4 V1. Okay. And this is 20 ohm. Fine. So now here is your V1 according to the question. Right. So ಇವಾಗ ನಾವೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ, we are trying to what? We are trying to what I can say find out the that is voltage using superposition theorem. So ಇವಾಗ ಏನ್ ಮಾಡಬೇಕು, you have to take the current I1, you have to apply mesh analysis again for this, right? How to sorry, just a minute, I'll just erase this things. Wait a minute, I don't have a space, right? So yeah, okay, so here it is. Wait a minute. Okay. So now if I apply the equation, so I get it as V1 is equal to, why V1 is equal to, I told you, the total voltage is equal to what I can say, the algebraic sum of all the voltages due to the each independent sources acting independently. It is response anta heltare, but that response might be current or voltage. Okay, yeah. So if you want to find out the voltage, then it is voltage, and if you want to so if you want to find what I can say the current, it is I is equal to response of all the currents, right? It is like that, fine. So now we are considering the voltage where V1 is equal to. So where V1 is equal to, what is that going to happen? You're going to get it as, that is your, this one, which one? That is 20 into I1 minus I2 because it's I1 first. And it is plus 0.4 V1. I told you positive to negative is always positive. Right? Okay. So we haven't found out V1. No, so that is right. So now V1 is equal to 20 I1 minus 20 into I2. So plus 0.4 V1 students. Now I have to shift the 0.4 V1 to the other side here, because there is V1 present over here and here also it is 0.4 V1. I need to subtract that. So if I subtract that, so it is a V1 minus 0.4 V1, 0.4 V1. So now, so see here, it is you have to find a current Ix. It seems Ix is nothing but I1 dash plus I2 dash plus I3 dash, so on, so it goes on. So like that, here it is the voltage. Voltage is equal to response of all the voltages. That is, it is the response of what I can say, algebraic sum of all the responses due to each independent sources acting in log. Fine. Okay. So now it is minus 0.4 V1, which is equal to 20 I1 minus 20 I2 students. Okay. So now here it is nothing but your V1 minus 0.4 V1. So it is that is 1 minus 0.4 V1 kali alva. So adike idu 1 anta agutte. So this is 1 minus 0.4, which I get it as 0.6, right? I get it as 0.6 V1. Which is equal to 20 I1 minus 20 I2. So just a minute, I'm sorry. I'll just arrange the space for writing for the continuation. Okay, yeah. Yes, I'll just arrange the space for further continuation. So please wait. Yeah. So now here, okay, so space has been arranged. I'll just write it here itself. Okay, yeah. So now here, what is that going to happen is that, so now we have to take V1 is equal to, I'll just write it here first and then come there. V1 is equal to, that is 20 divided by 0.6. What you get? For 20 divided by 0.6, you're going to get it as 33.333, right? So what you have to do, this V1 is equal to this 20 divided by 0.6 here. And this is once again here also it is 20 divided by 0.6. It is 20 by 6 I1 minus 20 by 6 I2. Right? It is, see, 20 by 6 by 0.6, I'm sorry, 20 divided by 0.6 into I1 minus 20 divided by 0.6 into I2, right? Yeah. So now what is that going to happen is that if you do this, you get for the first one it is 33.33. For the second one also it is the same students, but it will be minus 33.33 because here it is minus negative. Okay. So this is 33.33. It goes on 333. So you can take 3 or 4 according to your convenience. 3 or 4 in the sense like after decimal you have to take either 3 or 4 values. Right? So So I'll just tell you one thing that happens here. So what is that going to happen is that, so here you can see that it is and here you can see that it is ಇವಾಗ ನೀವು 33.3 ಅಂತ ತಗೊಂಡ್ರೆ ವ್ಯತ್ಯಾಸ ಬರುತ್ತೆ 33.33 ಸಾರಿ 33.3 ಅಂತ ತಗೊಂಡ್ರೆ ವ್ಯತ್ಯಾಸ ಬರುತ್ತೆ 33.33 ಅಂತ ತಗೊಂಡ್ರೆ ವ್ಯತ್ಯಾಸ ಬರುತ್ತೆ 33.333 ಅಂತ ತಗೊಂಡ್ರೆ ವ್ಯತ್ಯಾಸ ಬರುತ್ತೆ ಅದು there is a difference between, right? So according to the decimal you need to check it out, right? After the point how many decimal you take, according to that you get a resultant, right? If you take more decimals you will get the result, a different resultant. If you take less decimal after the point you will just get a different resultant. ಹೌದಾ? So point ಆದ್ಮೇಲೆ ನೀವು 1 decimal ತಗೊಂಡ್ರೆ different result ಬರುತ್ತೆ. If you take 2 decimal after the point you will get a different resultant. If you take 3 decimal after the point you will get a different resultant. So it is according to how you take it. Fine. Okay. And it is minus 33.333 I2. Fine, you got it? Okay. Okay, fine, you got it? Okay. So actually this question paper is our question paper. Which one? That is 17 EC35, that is network analysis. So why I am taking from this paper is because one question ಈ ತರ ಕೊಟ್ಟಿದ್ರು. So ಈ ತರ ನಿಮಗೂ ಕೊಡುವಾಗ so ಅದು ಪ್ರಾಬ್ಲಮ್ ಆಗಬಾರದು, ನಿಮಗೆ ತೊಂದರೆ ಆಗಬಾರದು ಅಂತ ಹೇಳಿ ತಗೊಂಡಿರೋಂತದ್ದು ನಾನು. ಓಕೆನಾ? So you just refer network theory only for your case. Network theory refer ಮಾಡಿ ಸಾಕು. ಸೊ ನೀವೇನ್ ಮಾಡ್ತೀರಾ ಅಂತಂದ್ರೆ ನೆಟ್ವರ್ಕ್ ಅನಾಲಿಸಿಸ್ ನು ರೆಫರ್ ಮಾಡಬಹುದು. ಯಾವ್ಯಾವುದಕ್ಕೆ ಅಂತ ಹೇಳಿದ್ರೆ if you want to refer network analysis paper ಯಾವ್ಯಾವುದಕ್ಕಂತ ಹೇಳಿದ್ರೆ so I'll just push it, please wait. ಯಾವ್ಯಾವುದಕ್ಕಂತ ಹೇಳಿದ್ರೆ ಫಸ್ಟ್ ನಿಮ್ಮ ಮಾಡೆಲ್ 1 ಗೆ ರೆಫರ್ ಮಾಡಬಹುದು. 100% sure you can refer network analysis paper for model 1. And for module 2 you can refer network analysis paper, but you don't have reciprocity theorem, right? Reciprocity theorem ಎಲ್ಲ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ನಾನು ತೋರಿಸ್ಕೊಡ್ತೀನಿ ಏನಂತಂದ್ಬಿಟ್ಟು. So reciprocity theorem ಇರಲ್ಲ, excluding that. Okay, excluding reciprocity theorem, excluding this you have to see all the things, that is Thevenin's and Norton's, superposition, Willemans and maximum power transfer. Fine. Now you can refer it for model number, what I can say, the 3. Model number 3 ಗೆ 100% refer ಮಾಡಬಹುದು. You can refer it for model number 3, right? And also you can refer it for model number 3 li ಏನಾಗಿದೆ ಅಂತಂದ್ರೆ so ನಿಮ್ಮ syllabus ಪ್ರಕಾರ according to syllabus of what I can say, the network analysis. So ನಿಮ್ಮ syllabus ಪ್ರಕಾರ please wait students, I'm sorry for the distraction, 2 minutes. I'm very sorry for the distraction in the middle. So there's a live going on, but I'm sorry for the distraction here. Yeah, okay. According to network, what I can say, the analysis for model number 3 you can refer even network analysis paper. Namma network analysis paper na refer ಮಾಡಬಹುದು. Okay na? Yeah. And for model number 4 also you can refer, no problem. For model number 4 also you can refer. But for model number 5 try to refer network theory paper. For model number 4 try to what I can say, refer the network theory paper. I'm sorry, not analysis, network theory paper. ಯಾಕೆಂದ್ರೆ model number 5 ಬಂದು it's a mixture of resonance and 2 port. So ನಿಮಗೆ ಹೇಗೆ ಕ್ವೆಶ್ಚನ್ ಬರುತ್ತೆ ಅನ್ನೋದು ನಿಮ್ಮ network theory paper ನಲ್ಲೇ ಗೊತ್ತಾಗುತ್ತೆ. So that is why you have to refer network theory paper for model number 5. For this model number 1, 2, 3, 4, you can refer or you have to refer network theory and network analysis papers. Network theory and network analysis paper, right? Network theory and network analysis paper. Now you have to refer for model number 1, 2, 3 and 4. For 5 it is only network theory paper. I hope you got the point out. So now coming on to this problem. So suddenly I had to tell you that. Okay, so because I have taken this one, so that is why. Fine. Okay. Okay. So this is reciprocity theorem, students, and this is not there for you. So I told you need to exclude this. So reciprocity theorem has to be excluded and all others has to be done. Your Milliman's is that. So please do only look at Milliman's problem. Don't look at reciprocity. Reciprocity is completely eliminated for you people. Fine. Okay. So now coming on to here. So now we got this. So this is what is my equation number 3, right? So now what is that going to happen is that you know that your I3 is equal to what I can say, that is minus 0.01 V1. Yes, what is your I3, students? Your I3 is nothing but is equal to, here I3 is nothing but is equal to what I can say, minus 0.01 V1, because it is positive to negative, this direction, the direction here. This is positive to negative, so that is why it is always negative. So therefore your current will be minus 0.01 V1, right? Now what I am supposed to do? I know V1 present, right? If I substitute V1 over here, so what is that going to happen is that I'll get it as a directly write the resultant. I will be getting it as what I can say, the 0. So here I will just write it. So first ಏನಾಗುತ್ತೆ ಗೊತ್ತಾ? So first ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ you will be what I can say getting it as 0. What I can say 0.333, not 0.333. You will get this equation. I'll just write it. 0.333 I1. What I can say, minus 0.333 I2. The same thing, right? Okay. So it is plus I3, which is equal to 0 na. You're going to get this right? V1 substitute ಮಾಡಿ minus 0.01 ಎರಡಕ್ಕೂ multiply ಮಾಡಿ ನಿಮಗೇನು ಸಿಗುತ್ತೆ? You will get the proper resultant. You will get the proper resultant, right? Okay. So this is what is you get, and this is what is my equation number 4, right? Now what I'm supposed to do is I'm going to take equation number 2, which is this equation. Which one? This. Minus 20 I1 plus 100 I2 minus 30 I3, which is equal to 0. This equation you need to take first, and this equation you need to take and substitute in your calculator, right? How we have to substitute in the calculator? Mom, 3 there, but nam equation bro there two equation, but I have 3 variables, say I1, I2, I3. How can I do it? Simple. You know that I1 is equal to 5 ampere. Try to substitute I1 is equal to 5 ampere over here. So this 20 into 5 becomes equal to 100, right? You get it as minus 100 plus 100 I2 minus 30 I3, which is equal to 0. If you substitute minus 100 to the other side, you get it as 100 I2 minus 30 I3, which is equal to 100. That is one equation. And here if you try to take 0.333, right? 0.333 into 100, if you into 5, I'm sorry, into 5, if you take, what is that you're going to get? You're going to get it as 1.665, right? 1.665 minus 0.333 I2 plus I3 is equal to 0, or I'll be getting it as minus 0.333 I2 plus I3, which is equal to minus 1.665, or what is that going to happen is that you get it as 0.333 I2 minus I3, which is equal to 1.665. How? So ನಮಗೆ ಏನು ಸಿಗ್ತದೆ ಇಲ್ಲಿ 0.333 I2, what I can say plus I3, which is equal to minus 1.665 ಬರ್ತದೆ ಅಲ್ವಾ? ಸೊ ಇವಾಗ ಇಲ್ಲಿರೋ ಮೈನಸ್ ಹೋಗಿಸ್ಬೇಕಂದ್ರೆ ನೀವು ಇಲ್ಲಿ ಮೈನಸ್ ಕಾಮನ್ ತೆಗೆದು You have to write it as 0.3333 I2 minus I3, which is equal to minus 1.665 ಬರುತ್ತೆ. So ಇದನ್ನ ಮತ್ತೆ ಇದನ್ನ cancel ಮಾಡಿದಾಗ you will be getting this equation, right? Try to substitute this in the calculator. The two equation, that is one as 100 I2 minus 30 I3, which is equal to 100. That is this particular, and ಇಲ್ಲಿ I1 substitute ಮಾಡಿರೋದ್ರಿಂದ ನಮಗೆ ಏನು ಬರುತ್ತೆ 100 I2 minus 30 I3, which is equal to 100. and ಇಲ್ಲಿ ನೋಡ್ಕೊಳ್ಳಿ ನೀವು, so you get it as 0.333 I2 minus I3, which is equal to 1.665. If you substitute in the calculator, you are going to get the resultant as I3 is equal to minus 1.4814. What is your I3? First let me write I2. So I2 is equal to how much you get? I2 you get it as what? That is 0.555 ampere. And your I3 is equal to, that's is equal to how much? It is 1 point, how much? 1 point minus 1.4814 ampere, right? And how do you get V1? So ಇವಾಗ ನಿಮಗೆ V1 ಹೇಗೆ ಸಿಗತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, so ಇವಾಗ ಇಲ್ಲಿ V1 ಬಂದಿದೆಯಲ್ಲಮ್ಮ, ಮತ್ತೆ V1 ಮಾಡಬೇಕಾ? Yes, you have to do it. How was that? You know what is I3? So you know what is I3? I3 is equal to minus 0.01 V1, right? I3 is equal to minus 0.01 V1. I'll just write that also, see here. I3 is equal to minus 0.01 V1, or your V1 is equal to I3 divided by minus 0.01. Okay, na? So you have to divide minus 1, what I can say, that is minus 1.4814 whole divided by minus 0.01. Students, you are going to get it as 148.14. What is that you are going to get? Just a minute. It is what I can say, minus 1, this will get cancelled, no? Minus 1.665, and here you had a minus, which I am cancelling it out. Fine, I am cancelling this minus, okay na? Yeah, so you get it as 148.14. So now my V1 is what? 148.14. How V1? This I3 you know it as minus 1. What I can minus 1.4814. How dalva? Yavdu I3. So that I3 has to come here. Let us substitute that. Divided by minus 0.01, which is 148.14. Fine, you got it? Okay. So ivaga V1 bantu. So ನಮ್ಮ next process ಏನು? So ನಮ್ಮ next process ಏನು ಅಂತ ಹೇಳಿದ್ರೆ, so we have to find out PAB to find out the power delivered by the dependent source, current source, that has 0.01 V1. So for that what you have to do is you have to do the same process of superposition theorem. So ಅದಕ್ಕೆ ಇಲ್ಲಿ ನನಗೆ ಬರೆಯಕ್ಕೆ ಜಾಗ ಇಲ್ಲ, so I'll just show in the scheme of valuation. Please wait, I'm moving forward. See, did we get this equation? Right. See, 5, and here also we got the same, and this also we got the same, right? Is it not? We got this. Yeah. Did we get this? Okay. So did we got the resultant? Yes. Now, so here also. So ಏನಾಯ್ತು ಇಲ್ಲಿ ನಾವು ಇಲ್ಲಿ ಏನು ಮಾಡಿದ್ವಿ? We just open circuited the dependent source. ನಾವೇನು ಮಾಡಿದ್ವಿ? ಡಿಪೆಂಡೆಂಟ್ ಸೋರ್ಸ್ ನೆಲ್ಲ ಏನು ಮಾಡಿದ್ವಿ? ಡಿಪೆಂಡೆಂಟ್ ಸೋರ್ಸ್ ನೆಲ್ಲ ನಾವು ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಮಾಡಿದ್ವಿ. So that is after we open circuited the dependent source. So what is that going to happen is that you got this resultant. And ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ಅಂದ್ರೆ equation ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ಅಂದ್ರೆ we are taking it in anti-clockwise manner. So this is clockwise. So ನಾವು ಹೀಗೆ ಬರ್ತಾ ಇದೀವಿ. So ಇಲ್ಲೇ ಮೆನ್ಷನ್ ಮಾಡ್ತಿದ್ದಾರೆ ನೋಡಿ ಹೇಗೆ ಬರ್ತಿದ್ದಾರೆ ಅಂತ. So ಅದಕ್ಕೋಸ್ಕರ ವರ್ಕೌಟ್ ಮಾಡೋಣ. And now here as you can see that, so it is, what is your minus 30. So ಇಲ್ಲಿ 30 ಅಲ್ವಾ ಇದು? 30 ತಾನೆ? One is 20, one is 50 and 30. So ಹಾಗಾಗಿ that will become, so ಇಲ್ಲಿ ಬರೀತೀನಿ ನೋಡಿ ನೀಟಾಗಿ ಇದೇ ಡಯಾಗ್ರಾಮ್ಗೆ. So it is minus 30 into, ಅದು ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ ಇಂದ minus 30 ಇದೆ ಆಗಿರೋದು. So it is I3 minus I2, because always resistance is positive alva, so that is why I am telling you why we have taken minus 30, right? Okay. So and once again I3 minus I2, first I3 then I2, and once again it is positive 0.4 V1 which is equal to 0 students. And solve ಮಾಡಿ ಇದನ್ನ solve ಮಾಡಿದಾಗ ಏನು ಬರುತ್ತೆ, so minus 30 I3 and plus 30 I2 and it is plus 0.4 V1 which is equal to 0 na. Howda? Fine na? Yes? Okay. So now we have to substitute all the values students. All values substitute ಮಾಡ್ತಾ ಬನ್ನಿ. So I3 you know it as 0. minus 1.4814. So if you take minus 30 into minus 1.4814 ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಅಲ್ಲಿ ಮಾಡ್ಕೊಳ್ತಾರಿ ನಾನು ಹೇಳುವಾಗ, ಓಕೆನಾ? ನಾನು ಮಧ್ಯೆ ಹೇಳುವಾಗ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಅಲ್ಲಿ ನೀವು ಮಾಡ್ತಾ ಇರಬೇಕು, ನಾನು ಇಲ್ಲಿ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಓಕೆ, so you are going to get it as 44.442. what I going to get, you are going to get it as 44.442. what I can say plus 30 I2. so what is 30 into 0.555 ಏನು ಬರುತ್ತೆ? 30 into 0.555 you're going to get it as 16.65. 6 plus what now? So plus now 0.4 V1 ಅಂದ್ರೆ ಏನಾಯ್ತು? So that is 148.14. ನಮಗೆ ಏನು ಬಂತು? resultant 148.14 ಅಲ್ವಾ? 148.14 ಬಂದಿದೆ. 98 ಏನು ನಮಗೆ ಬಂದಿಲ್ಲ. ಸೊ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, 98 ಎಕ್ಸ್ಕ್ಲೂಡ್ ಮಾಡ್ತಾ ಇದೀವಿ. ನಮಗೆ 98 ಬಂದಿಲ್ಲ ನನಗೆ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಅಲ್ಲಿ. ಓಕೆನಾ? 148.14. ಸೊ I'm sorry, there's 148. I'm sorry students, there is something here. Okay, let's clarify. So please wait. Yeah, so it is how much? So you got 0.4 into 148.14, correct? So you're going to get it as 59.256. Okay, 59.256 ಬರ್ತದೆ, which is equal to 0 now for us, right? This will be is equal to 0. and ಇವಾಗ ಈ ಮೂರು ಆಡ್ ಮಾಡಬೇಕು. ಸೊ ನಾನು ಹೇಳ್ತೀನಿ ನೋಡಿ, it is 44.442 plus 16.65 plus 59.256 which will be is equal to, that is 120.348. ನಮಗೆ ಇಲ್ಲೇನು ಬಂದೆ 120.3669. we are getting it as 120. how much? 120.348. ಯಾಕೆ 348 ಬಂದಿದೆ and ಇಲ್ಲಿ ಯಾಕೆ 3669 ಬಂದಿದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ಒಂದು 498 ಇದೆಯಲ್ಲ, ಇದರಿಂದ ವ್ಯತ್ಯಾಸ ಆಯ್ತು. ಸೊ ನಿಮಗೆ ಪಾಯಿಂಟ್ಸ್ ಅನ್ನ ವ್ಯತ್ಯಾಸ ಆಗುತ್ತೆ. after the decimal, after the point, I'm sorry, after the point how much decimal you take, it's according to that, right? after the point how much decimal you take, it is according to that you get your resultants, right? that also matters a lot. Fine. So now let's substitute. Let me take my value itself. So 120 banta. Okay, so 120 bandide anta andre is proper. So after the point whatever the decimal you take, according to that you get the resultant after the point also. So after the point ಈ resultant ಏನಕ್ಕೆ ಬರುತ್ತೆ, ಈ 348 ಏನಕ್ಕೆ ಬಂತು, ನಾವು after the point ಏನು ಡೆಸಿಮಲ್ ತಗೊಂಡು ನಾವು ಸಾಲ್ವ್ ಮಾಡಿದೀವಿ, ಎಷ್ಟು ಡೆಸಿಮಲ್ಸ್ ತಗೊಂಡು ಸಾಲ್ವ್ ಮಾಡಿದೀವಿ, ಅದು 1 2 or 3, according to that you've got this 348. okay na? Yes. now so now I have to take, that is power at 0.01 volt, which is VAB into 0.01 volt, right? VAB into 0.01 V1, right? So like a VAB, VAB is nothing but 120.348. if you do into 0.01 into 148.14, so 148.14 into 0.01 in ಮಾಡ್ತೀರಾ, it is 1.4814. yes, 1.4814 ಬರುತ್ತೆ. and that 1.4814, that is 0.01 V1 ಮಾಡಿದಾಗ you get 1.4814, that is 148.14 into 0.01. ಹೌದಾ? so that 1.4814 into VAB, that is for us it is 120.348. if you do that you get the resultant as 178.283, that is volt, right? 283 watts. right? There's 178.283 watts. ನಮ್ಗೆ ಇಲ್ಲಿ 323 ಬಂದಿದೆ. ಯಾಕೆ 323? It is because according to the decimal that you take after the point it comes, right? ಗೊತ್ತಾಗ್ತದ್ಯಾ ನಿಮಗೆ? So I hope you got the whole problem in detail. So whole problem superposition theorem ಮೇಲೆ ನಡೆದೋಯ್ತು, ಪ್ಲಸ್ ಮೆಶ್ ಅನಾಲಿಸಿಸ್ ಮೇಲೂ ನಡೆದೋಯ್ತು, ಹೌದಾ? ಸೊ ಈ ತರ ಕ್ವಶನ್ ಕೊಟ್ಟಾಗ ನಿಮ್ಗೆ ಹೇಗ್ ಮಾಡ್ಬೇಕು ಅಂತ ಕನ್ಫ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಸೊ ಹಾಗಾಗಿ what I have come up with is I taught you this problem so that you'll understand in a better manner. Hope you understood this problem, students. You understood, right? Yes. So ಈ ತರದೇ ಇನ್ನೊಂದು ಪ್ರಾಬ್ಲಮ್ ಇರಬೇಕು. ಸೊ I think that I have done that. If I have not done it, I'll do it. If I have done it, I'll just share the link on the description box. The same description box and a link ಹಾಕ್ತೀನಿ. I still remember that I've done it. If I've done it, I'll just put the link on the description box. So ಆ ಪ್ರಾಬ್ಲಮ್ ನೋಡ್ಕೊಳ್ಳಿ. And if I'm not done, I'll just do it again. ಓಕೆ. ಆ್ಯಂಡ್ ನಿಮಗೆ ಏನು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಹೇಳಿದ್ನಲ್ಲ, ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಆಲ್ರೆಡಿ ಒಂದು ಸಲ ನಾನು ಮಾಡಿದ್ದೀನಿ. ಇಫ್ ಯು ವಾಂಟ್ ಇಟ್ ಐ ಜಸ್ಟ್ ಡೂ ಇಟ್ ಅಗೇನ್, ರೈಟ್? ನಾನೇನು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಹೇಳಿದೆ ಇನ್ ದ ವೆರಿ ಬಿಗಿನಿಂಗ್, ಟೇಕ್ ದ ಪೊಲಾರಿಟೀಸ್ ದಟ್ ಐವ್ ಟೋಲ್ಡ್ ಯು. ಸೊ take this polarity that this one. I'm sorry for the distraction. Wait a minute, I guess it came down. ಇದೇನು ಹೇಳಿದ್ನಲ್ಲ, ಸೊ ಇದನ್ನ ನೀವು ಟ್ರೈ ಮಾಡಿಬಿಟ್ಟು ರಿಸಲ್ಟ್ ಚೆಕ್ ಮಾಡಿದ್ದೇನೆ, ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಹೇಳಿದ್ನಲ್ಲ, ಅದನ್ನ ಇಫ್ ಪಾಸಿಬಲ್ ಐ ಡೂ ಟುಡೇ ಈವ್ನಿಂಗ್ ಅಂಡ್ ಶೋ ಕೇಸ್ ಟು ಯು, ಸೊ ದಟ್ ಯಾರ್ಯಾರು ಹೊಸೊಬ್ರು ಇದ್ದೀರಾ ಅವರೆಲ್ಲರಿಗೂ ಗೊತ್ತಾಗುತ್ತೆ. ಅಂಡ್ ಬೈ ದಟ್ ಐ ವೈಂಡ್ ಅಪ್ ದ ಮೆಶ್ ಅನಾಲಿಸಿಸ್ ಸೆಷನ್. ದೆನ್ ವಿಲ್ ಕಮ್ ಟು ನೋಡಲ್ ಅನಾಲಿಸಿಸ್ ಅಂಡ್ ಸೂಪರ್ ಮೆಶ್ ಅಲ್ಲಿ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಬೇಕಾಗಿತ್ತು, ಅದನ್ನು ಮಾಡಿಲ್ಲ ಅಲ್ವಾ? ಓಕೆ, ವಿಲ್ ಡೂ ದಟ್. ಓಕೆ, ಯಾ, ವಿಲ್ ಡೂ ದ ಪ್ರಾಬ್ಲಮ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಸೂಪರ್ ಮೆಶ್ ಅನಾಲಿಸಿಸ್. ಸೂಪರ್ ಮೆಶ್ ಅನಾಲಿಸಿಸ್ ಮೇಲೆ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ನಾವು ಮಾಡೋಣ. haven't done it, right? I'm sorry. Yeah, we'll just do the one problem on super mesh analysis, that experiment, and by that we'll just wind up the session on mesh analysis, and then we'll come to the nodal analysis, students. Okay, so we'll just come to nodal analysis anta helta. I'll just wind up the session, students, and thank you.